Hello everyone and welcome back to this next lecture in the machine simulation series, and this is where we had left off last week, where we had printed out all the different values that we had computed. So these values that we had computed are the parameters of the equivalent circuit of the transformer, and that is this particular equivalent circuit. So as we already said, we can represent the single phase induction motor, and for that matter almost any machine in a per phase equivalent circuit can be represented by some form of an equivalent circuit which represents both the stator and the rotor, right? And of course, since it's a machine, there is a speed dependent term, which is the slip. The slip is defined as the difference between the synchronous speed and the actual rotor speed. So now that we have computed all these different parameters and we have printed it out, so for example, let me go back to the simulator and we can even run the simulation again. So the plan is, let's go back to the main page to view output, and if we run the simulation, we can go back to the console and we see these are all the parameters. Now there is, however, one problem, and you can see that problem is pretty obvious. That is, we are calculating the parameters in every simulation instant, right? And the reason is because we have it in the main part of the control, in the main part of the control file. So this is executed at every simulation instant, irrespective of the fact that these parameters will not change. And that is the first thing we need to do. We need to make sure that these parameters are computed at the beginning of the simulation and then after that are used only. So in this simulation, let's start with that. Let me just restart the circuit simulator. And let's go to the web browser and refresh the page. And we can click on stop. So with this, we can start with this lecture. In this lecture, we will just reorganize our code a little and start bringing in the concept of an actual control file. So as usual, a little bit of brief background that if you're interested in these kind of video lectures, but you would like something a little more comprehensive, I do have full-length online courses which you can find on my own website, which is pythonpowerelectronics.com. So this is the homepage of this website, of this project, pythonpowerelectronics.com, and in this you can find most of the information about this website on these 4 buttons, and also by all means scroll through the rest of the page. So to check out the courses, you need to click on the button Learn. So if you click on the button Learn, it takes you to the page with all the courses as of now. So I have 5 courses which I will go through gradually. So the very first course I have is Simulating Power Electronic Circuits using Python, and in this I talk about the basics of how you can use Python and Python Power Electronics to simulate power electronic circuits. The second course I have is Basics of Digital Signal Processing for Power Engineers, and in this I talk about how you can use Python and Python packages like SciPy and the signal package within SciPy to design and analyze filters for power engineering applications. The third course I have is Simulation of Magnetics for Power Electronics using Python, and in this I talk about how you can use Python and Python Power Electronics to simulate magnetic components like inductors, coupled inductors, and transformers. The fourth course I have is Control Analysis with Python for Grid Connected Converters, and in this I talk about how you can use Python and Python packages like SciPy and the Python control package to analyze and design controllers specifically for power electronic applications. And the last course I have is Why Specialize in Power Electronics. This is a free motivational course targeted towards either junior undergraduates or high school students to tell them about the challenges and opportunities available in power electronics so that they may choose power electronics as their specialization as they go into their senior years. So all these courses are available on 2 platforms, that is Decibels Labs and Udemy, and you can click on these buttons to take you to the link. So this link for this page is provided in the description of this video. If you're interested, please do check it out. So with this, I'll return back to the lecture. So the first part is, let me go back to the main page and go to control, and let's go to the induction motor control.py. So here we are going into the control interface. So here you see the interface is completely blank because until now we were only computing the parameters. So the first thing I'm going to do is I'm going to introduce a time event variable. That is, we want to execute this in time events. But even before that, right, even before that, the very first thing is we need to make sure that this computation is done only once, right? That's the first thing we need to do. The second thing we need to do is we need to make sure that even though we have computed only once, the important parameters, all right, all these that we need are always available to us, and for that we need to define these as static variables. So this is what we're going to do in this lecture. So the first thing is, the first one is I'm going to put in a static variable, and this static variable is called init simulation, which means initialize the simulation. And I will give it a value of 1.0, right? And I'll tell you why, because this 1.0 means that this is now an initial simulation. That is, the simulation is being initialized, and we can use this in our control code. So let me go and copy this variable and go over to the editor, and let me use it here. So what I am going to do is I'm going to come here and let me probably come here and use it here. So let me say if init simulation is greater than 0, in that case I'm going to perform all these computations. Right? Only if this init simulation is greater than 0. And if you see that because init simulation has been initialized to 1 in the beginning, it will compute all these variables. That is, it will perform all these computations and it will determine the parameters of this equivalent circuit. All I have to do is then, after my calculations, set it to a value less than 0, because my check here is it greater than 0. So after performing these calculations, if I set it to -1, this block will not execute again. So if I come over here and now let me go back to the main file and let me run on this again, and let me go over to the console, and now if you see, it appears only once, right? These parameters which are printed, which were being printed continuously because they were being executed at every time instant, is now appearing only once in the console because they are being computed only once at the beginning of the simulation. The simulator is still running, right? The simulator is still running, and you can see that this is still running. It's just that my computations are performed only once, and after which they stop. So this now solves one problem, that is, we are not repetitively computing parameters when it is completely unnecessary. It is of course possible to change these parameters later if you want to include things like temperature dependence or things like that. It is always possible, but however there's no need to perform all these basic calculations. Now however, there's one problem. In Python, a variable exists only when it is created. So for example, these variables vrated and pout and so on, they come into being when they are given a value, and if they are not given a value, they do not exist. Unlike other programming languages like C++ and Java, where you have to declare a variable and that's when a variable comes into existence, in Python there is no variable declaration. A variable comes into existence when it is given a value. Therefore, in the beginning of the simulation, when we compute these variables, they come into existence. But after this initial simulation, when we are setting this variable to -1 and this block is not computed, this entire code block is not executed, which means these variables do not exist, right? And I can give you an example. Let me come over here and try to print vrated. All right, so this is outside the block. Let me just leave some space here. So this is outside the block. Remember, in Python, indentation is everything. So let me go over now back here again and let me run this simulation. And you see there is an error. The reason why there is an error is because now this variable doesn't exist, right? We are printing this value. It is computed only once. It appears once, and that is because in this first iteration, when it is computed, it is printed twice. But after the second time, it doesn't exist, and therefore it is throwing an error. Now this is of course a problem for us. This is a problem for us, and the reason is because we need these variables always, because we are now going to use these variables in our computations, because we are now going to build a machine model, and that machine model has to be there for every instant of time and not just the beginning. So the way to solve this problem is we will define all these as static variables. So let's go back to the main simulation. Let me go back to the main page, to the control file, edit control. So we can start adding some static variables. So here I need to just start copying variables. So let me just come over here. And they can all be initially 0, doesn't matter. And here again, it is up to you, because not all variables are necessary. So for example, some of these variables may not be necessary. They may be only internal variables that need to be calculated only once. So you can use it selectively depending on what you need and what you think are just intermediate variables that don't need to be computed. As an example, we do need the synchronous speed. But I don't see a reason why we need P in rate, because P in rated is something that we have computed assuming an efficiency. So this is something I'm going to skip. Let me go over and declare I rated. And these are extremely important because these are the equivalent parameters. And this is the magnetizing inductance. And the last are the rotor parameters. And with this we are done. So these are all the parameters that we are computing, or we think we might need. If you need, we can even add more variables. It doesn't really matter. There's no limit on how many static variables we can have. In general, the rule is that in any computation, either you should define a variable at the head of the file, like for example, if it's a constant. If you're defining a constant, like you're defining pi, you're defining some other Boltzmann's constant, anything else, if you define it at the head of the file, it's a constant. But if it is a variable that can change its value, then in that case, the best thing to do is to actually go over and define it somewhere here. So for example, we can even add some of these variables that we have all the way up here. And this is actually a good idea. So along with that, let us also add the number of poles, because this is something which is useful. And this is something that we will use later in our machine model. Even when we do develop a machine model, we will find that there will be some variables that we need, and those variables we can always add. Of course, every simulation always evolves. It's impossible to get a simulation absolutely correct the first time. So these are more or less all the variables that we have, right? Now that we have these variables, let's go back to the main file and let's try to run it again and see if we get the error. And if we go over to the console, we see that the error is gone. But actually I removed it, so that's not right. Let me go back here. And let me stop the simulation, go back to the editor, and let me bring in that print command again. So like for example, V-rated. So I'm printing V-rated outside this block. This is in the main file. So if I come over and I run the simulation now, we should not see that error. On the contrary, we will be seeing 240 printed continuously because V-rated now exists as a static variable always in our machine model, and we need that because we will be using V-rated and all the other equivalent circuit parameters in building our machine model. So as always, you have to do a control interrupt. Let me start the server again and let me go over and stop the simulation. So with this, we are now ready with a simulation. Let me delete this. With a simulation in which we have computed all the equivalent circuit parameters, and we have made sure that these equivalent circuit parameters are computed only once in the beginning of the simulation, so that we don't burden our simulator with these calculations which don't have to be performed every time. What we can focus on in the rest of the simulation is building our machine model, and that's what we're going to start with in the next lecture. So with this, I'm going to end this lecture. In the next lecture, we will start by setting up the interface for our induction motor model. So as before, if you have any doubts, either do comment or send me a message or email me, whichever is your preference. Otherwise, I will see you next week where we will continue with this. Thank you so much for watching. See you next time. Goodbye.